Abby! My cat is stuck in the tree. Oh no.
Oh no!
Oh
What do you
no.
want me to do about it?
Can you use your ladder to get her down?
Yeah. How did you even get up there?
Well, I was looking at the tree and she just climbed in and then climbed higher.
Oh man. Alright, I'll go get my ladder.
Okay.
Watch out.
Oh, I hope Abby doesn't hurt herself. Maybe I can calculate the rate that the ladder would be sliding away from the wall, so I know how much time I would have to save her. Thank goodness Abby passed on the valuable knowledge of derivatives Mr. Tate taught her.
Mr. Toby.
Toby.
Okay, so this is the ladder, which is 6 feet, and the wall is 5 feet. And then we're looking for the rate at which the ladder is sliding away from the wall. And the ladder is sliding down the wall at 2 feet per second. So dy over dt is -2. And then dz over dt doesn't change, so it's just 0. And we're looking for dx over dt. So first you have to use Pythagorean theorem to find the other side, x, which we don't have yet. So we plug in 5 and 6 for the y and z, and then once you do that math, you figure out that x is equal to the square root of 11, which we rounded to 3.32. And then you have to take the derivative of the Pythagorean theorem to find the rate of dx over dt. So you do the power rule for each of the variables and then do implicit differentiation. So that's how you get 2x, or 2 times x times dx over dt plus 2 times y times dy over dt equals 2 times z times dz over dt. And then you plug in each of the variables. So x is 3.32, and then we don't know dx over dt. And then you plug in 5 for y and -2, which is dy over dt, and then 2 times 0, which is dz over dt, times z, which is 6. And then once you do that, you figure out that it's 6.64 times dx over dt minus 20 equals 0. And then you have to divide each side by 6.64 after you add over the 20, and you get that the rate is 3.01 feet per second that the ladder is sliding away from the wall, which means I have about 1 second to save Abby if she falls.
Thanks, Abby. I'm so glad I didn't have to save you. But I would have had time thanks to Mr. Toby. Better safe than sorry.